Welcome to Data Science 1, Probability, Geometric Experiments. All right, so here are the ideas we're going to use in this video. If you're not familiar with them, please go back and watch the videos that cover them, and probably the videos after them, because these ideas keep repeating themselves, and hopefully you're getting a good notion of what they mean. So the multiplication rule, random variables, and a probability distribution. All right, so we're doing Bernoulli experiments again. Yes, we are. We're going to continue on with the Bernoulli experiment. We did the Bernoulli experiment. We did it for binomial, and now we're going to do it for geometric. And here's the basic setup that we have two cases, and there's no in between. All right, so a geometric experiment is simpler to the binomial experiment in that we have independent Bernoulli trials. However, this one we're interested in the number of failures before the first success. So here the sample space is really easy to write. So there could be a success with no failures prior to it. But notice once we have a success, that's a terminal event. So then we have a failure and a success, or a failure, failure, success, or a failure, 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 success, and so on, which makes a random variable easy to define as well, because here, how many F's are there? 0. How many 1s are there? How many are there here? There's 1, 2, 3, 4, 5, 6. And in fact, there are countably infinite many values for this random variable. So sample space is extremely large. All right, so what we're going to do is we're going to say, well, if we have this easy to define random variable, then we have the probability P be the probability of success. Then we have probability of success equals P if X equals 0, right? Because there's one trial and it stopped then. If X equals 1, then we have 1 minus P times P. If X equals 2, then we have failure, failure, success, failure, probability of a failure, probability of a failure, probability of success. Then we have probability of failure, probability of failure, probability of success. And this is the formula. And if we keep up this logic, here's the distribution we end up with. We end up with f of x, which is the probability x equals little x, is 1 minus p to the x times p, where x equals 0, 1, 2, 3, 4, and so on. So let's look at an example. Suppose we know Hassan loves basketball, and when he shoots to score, he's successful 14.3% of the time. What is the probability that it will take Hassan exactly 6 shots to score a goal? Well, X is the number of failures, right? But if he's going to take 6 shots, then he had 5 failures. So 6 minus 1 is 5. Probability is 0.143. Plug this in, f of 5, the probability x equals 5. Run through the math, and we see that there's about a 6% chance that it will take him exactly 6 shots to score a goal. So pretty easy to use. You just kind of plug in the numbers and away they go. But let's look at one more. Asma is a real estate agent who is interested in selling residential properties. She knows that when she shows a property, there appears to be a 19% chance that an offer will be made on the property. What is the probability that she will get an offer on the 4th showing? So here, x equals 4, and this is supposed to be minus 1, equals 3. Okay, so that's what we're interested in, because we have to take off the success that happened that terminated the event, or terminated our series of events. P is 0.19. F of 3 is the probability x equals 3. Plug in all the numbers, work it out, and you'll see it's around a 10% chance that she will get an offer on the 4th showing. So these are not that hard to work with. Actually, I think they're way easier than binomial. You just have to have a good calculator and just plug it in. All right, so geometric experiment is another Bernoulli experiment. It's replication of a Bernoulli experiment as well. Sample space is countably infinitely large. Okay, and the random variable is simply the number of failures until a success. The probability distribution is easy to use for this really complex sample space. All right, so we're going to continue on with more of these in the next video, so see you there.